All right, 8th grade. Today we are going to be talking about discrete and continuous domains. This is Chapter 4, Lesson 2, Discrete and Continuous Domains. Okay, so a discrete domain is a set of input values that consists of only certain numbers in an interval. So an example of that would be the integers from 1 to 5. So you have 1, 2, 3, 4, 5, because there are certain numbers in an interval. A continuous domain is a set of input values that consists of all numbers in an interval. So the example here would be all the numbers from 1 to 5, including any decimals. So it's any number between 1 and 5. A continuous domain would include decimals. A discrete domain will not include decimals. Okay, so discrete are certain numbers in an interval, so they're going to be whole numbers. The continuous domain are all the numbers in an interval, including any decimals. So those are your key words for this lesson. Now we're going to do a couple of examples so you guys can see how to do this for your homework. So example number 1 is going to be, the function y equals 15.95x represents the cost y in dollars of x tickets for a museum. So it wants you to graph the function using a domain of 0, 1, 2, 3, and 4. And then it wants to know if the domain is discrete or continuous. Okay, so in order to graph this, first we have to figure out what our y values are going to be for our graph. So they told us what the input values were, what our x's were going to be. So we're using 0, 1, 2, 3, and 4. Okay, our function is 15.95x. So we plug those x values into the problem to give us the output, or the y. So with this one, 15.95 times 0 is going to be 0. 1 times 15.95 is 15.95. 2 times 15.95 is 31.9. 15.95 times 3 is 47.85. And then 4 times 15.95 is going to be 63.8. So our ordered pairs are going to be 0, 0, 1, 15.95, 2, 31.9, 3, 47.85, and 4, 63.8. And so then we're going to take those points and we're going to graph them on our coordinate plane. Okay, we know we have 0, 0, so we've got a point there. 1, 15.95, somewhere right there. 2, 31.9, somewhere there. 3, 47.9.85. 0.85. And then 463.8. Okay, and so we have our points and they're graphed. So then the question asks whether is the domain of the graph discrete or continuous. Okay, so we've plotted our ordered pairs, and we know that our domain is going to be discrete because you can't remember our input is our x value, and this is the tickets. You can't have a partial ticket, so our domain is going to be discrete. Okay, and it's discrete because you cannot buy part of a ticket. And so the graph consists of individual points. Okay, so our domain is discrete. Another example has us looking at another problem very similar to what we did before. And we're going to be talking about a cereal bar. So we have a cereal bar contains 130 calories. The number C of calories consumed is a function of the number B of bars eaten. So we're going to graph the function, and is the domain of the graph discrete or continuous? Okay, so in order to graph it, okay, we've got 0, 1, 2, 3, and 4. Okay, we're talking about our input, our X are the bars, our output, the C, are the calories. Okay, so if we have 0 bars, we have 0 calories because you're not eating anything. Remember, 1 bar is 130 calories. So 2 bars is going to be 260. 3 is 390. And 4 would be 520. So then our ordered pairs would be 0, 0, 1, 130, 2, 260, 3, 390, and 4, 520. Okay, so then we're going to take those ordered pairs and we are going to put them into our graph. So we have 0, 0, which is going to be here, 1, 130, 2, 260, 3, 390, and 4, 520. Okay, so we've got the 4, 520. We've got 3, 390, 2, 260, 1, 130, 0, 0. Okay, those are our points. Now, our question asks us whether the domain of the graph is discrete or continuous. Now, with our last one, we couldn't have a partial ticket, but we can have a partial serial bar. So, for this question, for question number 2, our example 2, the domain is continuous. So our domain is continuous. Okay? So you can eat part of the cereal bar, and B can be any value greater than or equal to 0. Okay, so our B can be greater than or equal to 0. Okay? So any number over 0 would be B. So our domain is continuous. Okay, and that is example number 2. Now we also have our third example. Okay, so you conduct an experiment on the speed of sound waves in dry air at 86 degrees Fahrenheit. So you record your data in a table. Which of the following is true? So our table has our input time represented by t, which is in seconds, and then our output, which is distance, represented by the d in miles. So at 2 seconds, the sound wave has traveled 0.434 miles. At 4 seconds, it has traveled 0.868 miles. 6 seconds, 1.32 miles. 8 seconds, 1.736 miles. And at 10 seconds, it has traveled 2.170 seconds. Okay, and so it wants to know which of the following is true. So A is the domain is t is greater than or less than 2, and t is less than or greater than 10, and it is discrete. The domain is t is greater than or equal to 2, and t is less than or equal to 10, and it is continuous. C, the domain is d is greater than or equal to 0.434, and d is less than or equal to 2.170, and it is discrete. Or letter D, where the domain is d is greater than or equal to 0.434, and d is less than or equal to 2.170, and it is continuous. So the first thing that we can do is we can easily cross off 2 of these answers as being incorrect. And the way we know that is we're talking about the domain, and the domain is the input values. So if we go over here and we're looking at the input values, C and D are talking about the output values. So C and D are not talking about the domain. They're talking about the range because those are the output values. So our answer is either going to be A or the answer is going to be B. So we are left with whether or not the domain is discrete or if the domain is continuous. And remember, with discrete is talking about only certain numbers. Continuous would be all numbers in an interval. So discrete is certain numbers in an interval. Continuous would be all numbers in an interval. And when we're talking about time, we're going to be talking about all numbers in an interval. And so A cannot be the answer because it's talking about discrete. With time, it would be continuous. So our answer is B. B is the true statement in those. Okay? Go ahead and do your on your own problems, and I will see you in class.